would do for part of the homework assignment. The homework assignment is posted now, not too long ago, under assignments for this course, and there's homework 1. There's a homework assignment. The PDF or the document there are the same, right? Same content, so either one that works for you. And a data set that we could analyze. What I will post later today, after I double check it a little bit more, as an R script file. So eventually I'll post something that will give some sample commands to help with that. So at the point of getting ready to do the work with the data set, you might download that flight delays data set onto your computer. There's another way to get it that we'll look at today. There'll be an R script file, and you might download that to your computer. So if I wanted to download this one from here, you just right-click on it. There's a save link as, and it will come down. And just like typical, this says put it in the downloads file directory. So if you want it in the downloads directory, you can have it go there. But you might, if you create on your computer some other file or directory, file folder or directory where you want to keep things to this class, you might put it there. So this network, did that find me? Right, so the Z directory, let's see, kind of that there. If I push that down, I don't quite understand what it's doing. Network. Something's kind of funny with how the network is working today. Oh, that's my stuff. There we go. Found it. This was a little slow. So if I wanted to put it in my course here, or where was that? So under the C drive, I have an account on this computer, on the one that's sitting underneath me here. If I wanted to put it into this class one, I could put it there, and then it would show up, and there it has it in that data set, right? So many times there'll be, because the data set from the book, there's a kind of real cute way to get it that's very convenient. But I'll give you some other data sets to use, and then downloading them from the Canvas site to some place that you know will be useful, right? And similarly, there'll be an R file there that you could download to the same place that'll be useful commands for doing things in R. So for instance, on the lectures, under the files where it has lecture notes, right? There was this, not there. There's this PCAP file that is R script. If I wanted to download that one, I could save that link as, and it would put it there. So in my directory, then I would have those couple of files that then would be useful for getting into R. So often, if you click on it and it looks like it's created some other funny file type or manipulated things, then just try it again. There's kind of a couple ways to do it. If you do kind of the preview in Canvas to look at it and then try to save the preview, that has changed things. So just right-click and download as well. So for this course, we're going to use R, our statistical package for computing. The book is built around that. It'll enable us to do a lot of simulations and graphs and use data for the purposes of studying mathematical statistics and the basis for different methods, right? And so to get R downloaded, I just type CRAN in the search bar, and this comprehensive R archive comes up. I click on it. There's Windows, Macs, and Linux. That comes up, and click on Windows for this machine. Right? It's a split between different types of machines. Just the base one and the download. If I click on this, it's going to download the executable file. I've done that before, so I'm not going to click on that again. It just takes a couple minutes. The typical place where this download would go it downloads. I'll go ahead and click it. Here down here it says it's down here, so eventually that will be finished, and I can just click on that and run it. Sometimes this disappears, or some people don't have it set to show their downloads. And so on the just on a file folder, there's usually a downloads window. And I've downloaded this a couple times. That's why there are multiple versions. Currently working on this one down here, but then it's downloaded. And once it's downloaded, you just simply click on it, or when it was back here at the Windows, whatever it was, that one, right? Or click on it when it shows down here, and you get the executable to go. Right? They ask if you want to modify the computer. It's okay. English is okay. Accept the agreement. Standard place to put things. When I click this, it's going to say that the thing already exists because I've already done it. But a couple more clicks and then it will go about installing R. Is anybody trying?
This is just right.
What?
This is just right. Just make sure.
Yep, that's right. That's how it goes. So I'm not going to do that because I've done that before. And then at that point, you'd have the couple of R icons on here. And one is kind of built for a 32-bit machine, and the 64-bit machines have a little more memory and data precision, and most of them are that way. Really, you could run either one. You just click on this, R starts up, and you see a very basic, just one window there. You can type things and do things in R there, but the RStudio kind of interface is a little more convenient. So I'm going to quit out of that. I'm not going to save the workspace because we haven't done it. The other software is this RStudio, right? So just typing RStudio.
You have an S in front of it.
RStudio. It might still figure it out. Google's pretty smart. And so here's this one. And it says download RStudio. Choose your version, but you take the free desktop one. If you're starting your own company and want the enterprise one or something. And then the type of machine, right? That goes there. So if you click that, it's also downloading it just like those others. Once it's downloaded, you'll have that completed down here in this, or in your downloads folder. There's RStudio's here. You click on that. You can modify your computer. There's a startup window, and again, it'll ask you to. I just click through the standard things, and pretty quickly it's installed. I'm not going to do it because I've done it before. And at least as it happened on this suit, and I've had it a couple times before, that I don't see an RStudio icon for some reason. I think I could probably get that shortcut on there, right? But I haven't done it yet. So if I just type R in this little search window, right, it comes with RStudio, and then RStudio will start. So I'll start RStudio. And it opens a window. And I think this is pretty much how you'll see it, right? Empty, nothing down here, and so on. And it's just kind of the preamble stuff. Right? To get rid of that preamble stuff, Control L will clear it out. So Control L will give you a blank screen, which is kind of nice. Every once in a while, it does kind of obliterate that whole history. So if you wanted to save stuff that you had done there, you might cut and paste to save a little bit before you do that. But if you have gotten a little place and saved some output, and I want to start a new thing, sometimes I find it there. Right, so that's going. So how do we get stuff in to R? The critical thing is letting R know where stuff is. Right? It's just like Microsoft Office or something like that. If you have the program going, and now I want to look at my document, you have to tell it what directory to look at. So one way to do that is just you can go to Open File, and knowing where it is. So I had this on this C drive, this R script. Well, here's a data set, this flight delay data set. this data set, for some reason, this computer is associating that with Minitab, just another statistical package. Maybe they have a CSV file style and somebody somewhere has done that. This data set, I'm going to open it with just Excel. I need to look at it. This is a flight delays data set. That's there, so it's an Excel style file, CSV, comma separated values, and it just looks like that with these different variables. So if I save that from the website and want to get it into R, but I got that, I went under File and Open File, and now I'm going to look for that. It's on this PC, it's on the C drive, under my name, under my name, and then under Documents and our class, and there it is. Right? So if I open that, okay, it's opened it. Oops. I actually want to do import data set, not just open. We want to import that data set. And so this first entry there is the one that's real convenient for just simple files like this. A plain text file that has tabs or spaces between or something like that. So for these, in our textbook, this first option will work well. So again, I have to tell it where to look. We'll point and click. And there it is. So what this will do is try and interpret what's in that file. I think it's thinking. This will pop up here in just a second, or it should. If you're doing this on your computers. There it is, it figured it out. So I read the file in, and it's called things V1, V2, V3, etc. like that. For some reason, it has thought that it doesn't have a header. Right? These things, we do want headers. I think it's counting the number of entries across here and number of these, because I don't know. So it's doing something. So it's not quite right. But we can tell it that it does actually have headers. Right? And if it does that, then it figures it out. That the first is ID carrier, and these are the names of the variables. Right? So if you do that, it will work out. Right? And this is a, let's see if I can do a little bit. Make it a little bit smaller, then it says it has an import button there. And so this is going to call, it's going to be called flight delays, and it's going to import that in. So now it's created an object over here. There's 4,000 some flights that it's tracking, right? 10 variables on each one. Right? And this is a little, you can't edit this. This is just a view, so you can check out what's there. I don't particularly need that, but I can close it for now. But any questions? Anybody trying that? And
I've got it.
You've got it. That works.
I'm trying it, I just can't find the data file.
Okay. The data file, did you download it off of Canvas?
I don't think I'm on the Canvas.
Oh, on the Canvas. So you're not on Canvas.
Yeah.
Not yet.
Also not on the campus yet.
You're not on the Canvas yet. Okay.
I just added the course information.
Yes. So what I could do, I can email it. Just like on Outlook.
Email, so we got it. Sweet.
So what's your last name?
Mulligan.
Mulligan. Mulligan, C, Mulligan, there you go. And Putnam, right?
Yeah.
And you might not have this either.
I think I have already.
You have this one? Yeah. Right. Okay. Data.
Did you want us to also download the PCAP file?
Yeah, we'll do something with PTAP. So
But do you want us to download the file?
you can, yeah, yes, you can download that one. So let's see. one, I'll send you this, a PCAP file. That's cool. Here's these other couple versions. On here, that's one thing, and then the other thing is this thing, that's PCAP flight delays. Okay. So I think those will go. So now in, I have too many things for this to work out so well.
I was just figuring out. Our studio.
So now flight delays is there. What? There are there's some Excel files.
Okay, I can use the Excel files.
Yep. Yep. And so there are, if you click on this little thing here, right, you'll see these different variables that are on there. And in the, right. So that's kind of getting in there. I want to more work with the PCAP data. Right? But that would be getting the flight delays data in that would be useful for the homework, right? The other thing for the homework is that to note about doing some of the homework in our book in R is that there is a website that's described in the preface to the book that's useful, right? So the authors, Chihara and Hesterberg, you just search on their names actually, their site comes up. And on their site, which you all can access, are some chapter materials and data sets. And for instance, there's data sets that are here, and the flight delays data set is there. So any of the data sets from the book, if you wanted to look at any of those others, could be downloaded. Or you could just download the zip file and have them all at once on your computer. The thing that does is if you get them all on your computer, then if you want to use one from class, you don't necessarily have to get down from the website, and it's already there. And also it means that at come project time, if there's another data set you want to look at, you have it all there to use. The other thing that there is these chapter materials, right, is that there are some R script files which give series of commands for many of the things that are in the chapters. You've noticed in the notes sections of the books, there's a number of commands, and many of them are here. So, yeah, if you let me download this one.
You did.
I did. It's gone into, let's see, documents. That's the one in class. I'll put it there so I know where it is. And so, let's see, where does this thing go? Now here in this class, I have this R script. It doesn't say R script in it, but it has this capital R. Usually when I make something that's a series of commands, I'll have the word R script in there in capital letters, so it's easier to see that it's a series of commands. But there's a series of things from chapter 3. You can download that like this. If I have an R script associated with the homework, you could download that one to the same place when you get the data set. To get that set of commands into R ready to go, right, if you open with RStudio, it will go into the program. And so here are a bunch of commands related to
Chapter 3.
chapter 3.
Wait, do you want us to download that?
You don't necessarily have to do that, but that would be the process of downloading it. For this thing, this is the one where if you do open file, you can pull the R script thing in as well. I'm going to open this PCAP R script because that will be something that we might use. those data. One thing that, if you look at this, is with these commands, right? So it's possible to read data directly from internet sites into R. So for instance, let's see. This one is this Beer Wings data set. The command that's given there, let's see if this one works. So this command here took the data set directly from that website and got the 30 observations and 4 variables for that particular data set. Right? It wasn't necessary to save it down to your desktop, your computer, and then read it in. For the ones that are in the book that we might use, that works as well. And I think it's possible, so I won't call it the same thing as the other one. So flight delays, right, data. I edited something by mistake there. Right. So just call it flight delays. The data set there is called flight delays. Is it capital? I can't remember if it's capitalized or not. So, it's the chapter material. This is the data set. And flight delays has delays as capital. So if we do this, it looks like flight delays is now a different copy of that same thing, but it came directly from the internet. Yeah.
Mine's sort of having trouble
Finding.
importing the data.
Does it?
Yeah.
Is it
No?
Did you get the files from email?
Yeah.
You have to convert them to Excel files.
One of them's already in the Excel file. It's getting in there. It's just like
Uh-huh.
doing this, and I can't really get down to the buttons. So really
Oh, okay. If it's too big, try Control minus. Control minus would make the file smaller. Control plus would make it the window smaller, right?
Yeah.
And
But it's
so-
still sort of like you can see as you drag it. Do
Yeah.
you see that?
Oh, okay. There's a little graphic in it. We'll try to import it anyway, because it looks like it has X, the carrier's age. It looks like it's
Okay.
seemed to still pulling in
Okay.
some of the things, yeah. Right, yeah, so in general, Control minus will make things on the screen smaller, Control plus make it bigger. So in terms of using R, getting some data sets from the book internet site or from the Canvas site, and then loading them in. Right? We're going to use as an example. Let's go, I quit out of this for now. Might be a little bit easier. This PCAP data set that's in CSV file. So I'm going to file import a data set, this base one, to do something. And under the C file, right, users and my documents. Right, here's this PCAP. That's not the data set. Get it. So it is, okay, I'm going to go to my directory over here.
It's called PCAP anon?
Yeah.
Okay.
The anon just means that it's an anonymous version of it. It doesn't have any. So here it is, PCAP anon. I'm going to open that. Just taking a moment to process it.
I would go to that way, click on the 3, include the 3 buttons at the end, click download.
That one's not a large data set, so it's taking a little while to get going here.
What'd you call it? Dat.
And then file.
Right. So it's figured out that there are headers, so that's good. Looks all okay. I'm going to change, in this R script, I'll just do the whole import with that long name. So it's got this data set of the 47, or the 81 children, let's close that. 81 children with those different variables, some that were in the PCAP program and had prenatal care for the mothers and advice about dental care of newborn children, and then the other ones that didn't. That's what the data set looks like, looks okay.
Do you want, do you want heading for this?
Yep. Yep. The headings are these names that are at the top.
Solid.
And so in R, LS, little brackets, that's the letter L, it's kind of a list of the files that are there. Shows that there's that beer wings I loaded in, a couple of versions of the flight delays, and this PCAP one, right? Now that PCAP name is pretty long, and I don't necessarily want to type that every single time. So you can either change that name when you read things in, or if I read it in this way, I can just say my DAT is assigned to PCAP. And this is, RStudio is nice in that sense. It kind of prompts me, and I can just press tab and get that. So now I've renamed it as DAT. The original one's there, but this other one that's smaller is also there too. I'm going to actually just remove some things. Some of these different things. So I'm going to remove that PCAP long name. So all I have is my DAT there, so it's not kind of cleaned up a little bit for my object. So if you have the PCAP script there, right, and that data set in there, if the R script has any of these commands written out here, you can either copy them and paste them down here, or hitting run will make them go. So the top few there are, those are the first few rows. Right, the next few rows, the names of variables comes up. DAT is stored as a matrix. So there's 81 rows for 81 different people, and then 4 variables are the columns. Right? And you get the rows and columns. And PCAP, right, to refer to just a single variable. And let's see, view, file, edit. I wanted to just look at one thing, view. Oh, I can, what is that, view, control. So, make this. Zoom in, make it a little bit bigger so it's a little easier to see. The PCAP values for the 81, and if you have the data set name, which in this case is DAT, and just the $sign, you'll see all the values, the ones and the zeros, right? If you tabulate that, you see the number ones and zeros that are there. So what I did in writing this, you know, that the colons here are just comments. They indicate a comment, so it doesn't execute anything. And I just copied the information from there. The ones are PCAPs, and so on. So you refer to the data values by ones and zeros rather than PCAP or not PCAP, because that's how it's coded. Right? And if we want to look at the averages, right? Let's do just a little review of kind of the whole scenario of what we're doing. Downloaded some things, uploaded some things, and doing a little bit of a sample program, right? And so this is the scenario where we have 2 groups. And so there are 81 in all, and they were randomized to either PCAP as a group or normal prenatal care at the Oakdale Hospital. PCAP, there was 37, right? And this is 44, right? And then at 2 years, in the children, they're going to count the number of dental caries. And compare these 2 groups. And so the basic hypothesis, right, is that, is there a difference? Does PCAP simply reduce the number of dental caries, right? And so we're going to look, the basic question, are the averages, average number of dental caries the same in the 2 groups, or are they different? Or you could phrase it as, is the PCAP lower on average? Is it a beneficial program, right? And so we're going to go through 4 steps, right? Setting up a hypothesis, getting a test statistic, doing an assessment of significance by simulating or computing a null distribution. That is, what would be the distribution of a null hypothesis, and then a conclusion. And so we're going to look at code for doing that, right, and run through it. So under the null hypothesis, we could write that as the mean for the first group equals the mean for the second group. U sub 1 could be the mean, the average number in the PCAP population. Right. And U sub 2 would be mean in the normal care, standard care. And then the alternative that we probably are interested in is that the first one is less than the second one, because we think that P-care would be beneficial. Right? So we set up our hypotheses, and then we need a test statistic. The most direct thing to do is to use the averages, sample averages from our 37 and 44 to estimate those things. Right? And so on, right. It's nice to have the screen to record things, but it's a little bit less flexible in terms of, right? It's going to be nice if this were twice as long and something like that. Right? So we compute a test statistic. We can compute the average for the first group and the average for the second group, and we'll take the difference, and that be our statistic. The value we get in PCAP, take the mean of the first group and the mean of the second group. We get that. The difference of those is about 3.37. The little dollar sign uses that variable, the caries, and then we want to take the subset of it, the square brackets inside of that. We put something to take a subset. And in this case, it's a logical statement. Right? Is PCAP equal to 1? There's 2 equal signs in there, and if that's equal, then it's true. And so if you take that subset, it reports the ones that are true. The other value is 0 in there, and so we're taking the difference of those. Those end up being our statistics. So let me do this here. This one ends up being 3.37, and this one is PCAP, and this is normal. You could even call this, my hand erased. Nope. Eraser, is that good? I have to switch back. Okay. And this is more of the standard. That's the letter C for PCAP. If I had to write, sometimes you might want to write Y bar P and Y bar S for standard. It's a little easier to keep track of what's 1, what's 2. Right? But now we need to evaluate this. We need the null distribution. of the test statistic. So to do that, we put all the, so there's a distribution of the test statistic under the assumption that that the average is 0. So here's that 3.37 large. Right? So we're going to set up, I can make this one big to look through things. So we're going to set up means if we had taken a sample of size 37 from a population, and then means if we had taken a sample of size 44. Right? Those are the sizes of our two groups. And to take our samples, we're going to take the 81 values that we had and randomly pick some of them and put them in group 1, and randomly take the other 44 that will be left over for the group 2. Yes?
Is R a 0 index?
Um,
Arrays?
So
Is the first element 0 or element 1?
element 1. Yeah. We'd start counting with row 1, row 2, row 3, or vector element 1, 2, and something like that. So we're going to do it 1,000 times. So we're going to do this loop 1,000 times, and we're going to randomly pick 81 row numbers, 37 row numbers from those first 81. This colon, right? So if you had 1 to 8 instead, right? So that 1 colon does numbers going 8 to 1. You can make it go the other way. It can go down. Kind of a flexible way of doing numbers there. And so we're going to take the mean of the data carries, and we're going to take the ones only where those indexes that are selected. So the first one will have 37, and that's why I called it 37. And the other ones, the minus there means take it out. So we take out all those indices that are there and save the mean there. So it's going to go through this loop. This is the closing of the loop. And then we're going to take the differences between those two vectors. Right? There's 1,000 in this one and 1,000 in this one. And we take the pairwise difference. And so we get 1,000 differences here. And run that. So it goes pretty fast. Just click through those things. You take the difference, and we have 1,000 differences. And this is a little squashed. That looks better. And so where is our 3.37?
Off the chart.
Yeah, a little bit off the charts, right? So in R, you can adjust the graphics. So we can make the histogram go, the limits be negative 4 to 4. Make it a little bit wider, and then we can put in a little line to show where that would fall. Right? So our observed one, our actual value, right, is bigger than any random simulation that we were able to generate under that assumption that there's really no difference between the groups. If we're looking at how many of these things are greater than or equal to 3.37, there's none of them. If we divide that by b, then 1,000, that's also 0. The book, in a little note, says that it likes to add 1 to the numerator and denominator because there was the original sample. That won't really make much difference, right? Because to simulate a distribution, this number b, we never take it to be 10 or 20 or something like that. 1,000 seems very, very relevant, right? But maybe you want more, right? So say you wanted to change to more. 1,000 is pretty good, but 10,000. You could do 10,000 or 100,000. And all it would be doing is changing that one bit of code in there to make it bigger. And then it will run. You don't necessarily have to reset the random number seed. And so it pauses for a little while before it finishes now, but it's pretty fast. And the difference, the histogram looks like that. And this number looks like it's still above all those. So, 7 of them were bigger. There's actually 7 out here, but it's just very, very small. So we would interpret this as the p-value for evaluating this hypothesis is really small, much less than 0.01. That doesn't happen, you know, if the null hypothesis is here at 0, the chance that we would get something this big is almost unbelievable. It's like a rare occurrence. Right? And so for small p-values, we're going to conclude that we don't believe that they're equal. And in fact, it's pretty convincing that the p-cap has lower dental caries at age 2. Now, the book shows something called an empirical cumulative distribution function. So the book, with its graphics and some things, throws in a little terminology here and there. And this empirical CDF is one thing. So let's look at what it looks like. The empirical CDF is a plot. We play on the differences, and there it is. It's going up like this. Right? It has these little x values. So these are the values of difference that are there, and then something f of n of x. And our observed difference, 3.37, is here. So see, there's a few of them above that, but most of them are below. Right? And so what this thing is, it's just a graphical way of looking at a distribution of values. So this empirical CDF, right? So empirical, So empirical as opposed to theoretical. Right. So if we had a theoretical probability distribution, we could do a similar plot based on theory and computations. But in this case, we're simulated values, and so we're plotting the actual numbers that we've gotten from the simulation. Right. So empirical cumulative distribution function. Or CDF. So this is something used in probability theory. It's not a critical component of understanding what's going on. Right? If you just do the histogram, kind of the relative frequency of things, and see that our value's really extreme, that's enough. What this thing does is it takes the different values we have. Right? So you have a whole bunch of values going along. You know, you have a bunch of values, right, that you observe in a sample. You go out and measure the number of dental caries or something like that. And then it's 0 until you hit the first one. And then it pops up a little bit. Right? And then it goes along until you hit the next one, and then it pops up a little bit. And then you go along, and every time you hit a sample point, it pops up. So sometimes it goes up more steeply and so on. So it keeps going up this step by step, until it gets to the last one. And at the last one, then it finally hits 100% of the data and is at 1. So some data sets will have kind of a smooth increase along there. Some data sets will that make it red? Some data sets start out, and then they have a lot of their observations right away, and then they kind of go slow. That red one, right, might have a bunch of observations here at the beginning, and then a few really big ones. Right? This is something that is kind of skewed to the right, meaning that there's most of the points here, and then a few long tails sticking out there. Some extremes would have that long tail. Right? On the other hand, if you had a distribution that started out without very much happening in a few cases, and then everything kind of happened, all your values, it would start out more slowly and then kind of have a shoot up much faster. But it kind of shows, it's another way of representing how the growth of the frequency of values as you go along. Right? And in some areas of statistics, they would use more histograms. Some areas like survival analysis and things in medical studies might use more of these waiting times or cumulative times and things. And if our test statistic is in this tail where there's very little data, or way down here where there's very little data, that's going to be like a histogram of the simulated values where we're way outside of the edges. And so it's called empirical CDF. The cumulative distribution function is often denoted by, f of x And what does our book, what does this one use in R?
R uses F, capital F, lowercase n of X.
Yeah, so to emphasize that it's based on n observations, right? That it's empirical, that it's actually the step function. This one doesn't look much like a step function, but we have 100,000 observations, so there's very small gradations of steps. And so that's all that is. It's another way of displaying the data. And in most of the things that we'll do, we can look at both a histogram and this, right? Or one or the other, right? to do it. Right? Okay. But it's always good to look at the data. Here's the data the original data carries. And here's the data for the ones that got PCAP. Here's the data for the ones that did not have PCAP. So you see that there's some kind of a noticeable difference in the distributions between these two groups. The ones that had PCAP had a lot of zeros, ones. Their kids are not getting those. There's still some people, some of these small children that are getting a lot of cavities and decay right away. And the ones that do not have PCAP and that advice and training and are much higher. So you kind of visibly can see some differences there. A box plot's another way of looking at that. And this type of formulation in R, we will see as we go along, that things are often written in this kind of little, it's called a model statement framework, right? So carries as a function of PCAP. There's a little tilde in there, which data sets. So it tries to split the data into two groups according to levels of PCAP, right? And the ones are they did have PCAP, and 0 they did not. And generally that distribution is shifted toward the higher values of carries, right? Now, some people might not like to use means, right, for things, right? These samples are not really large. Right? There is at least one kind of point that's a little bit larger in that group that kind of looks like an outlier. You could have a data set that's more extreme. So somebody might want to use medians or some other way of measuring the center. Right? So let's imagine another procedure for comparing these groups. Right? We could have a different hypothesis. I'll switch back to this one. The median number of carries in PCAP, right, is equal to the median number of dental caries in the standard care. So maybe we can make a hypothesis about a different parameter. In this case, the median is the parameter describing the distribution or the population characteristic, right? And versus an alternative, right? That's simply that they're not equal, or maybe that the median, of the PCAP median is less than the median under standard care. There's not really a standard notation for median, a Greek letter like that, right? So to do this, we'll need a test statistic. Right? The first step, set up hypothesis. Second one, set up a test statistic. You can have the median PCAP, the sample median that is, minus the sample median, right, under the standard care. So what's the value of this statistic? Why don't you work a couple of minutes and try and get that value? Want to try and do that? Here was the code that we used for means. Make it a little bigger. think about that. So instead of mean, what do you think you would type?
Median.
Median, yeah. There's a median command. So I'm gonna cut and paste a little bit. Nice thing about the R script, having those commands saved, sometimes you can cut and paste and save some time for things like that. What you get is the median for,
PCAP?
yeah,
0.
0. So median p-cap in this picture, the dark line in the box plot, 0. And for the standard care,
5.
yeah, I got 5 here. Is that working out for? So our sample statistic in this case is actually a little bit wider, right? So, well, I put 0, -5, so maybe the statistic would be called -5. You could do it either way, but if I did it this way, I would call it -5. In the end, you interpret things according to the original scale, so PCAP looks better. Right? However, whatever a negative means in this case, right? So then we want to evaluate this. We need the distribution of this under, right, so if these are all changed to median. It looked like in my code, I'm doing PCAP 0 minus that, so it's giving a value of, okay, let's see. 0, 5, and 5. Right? So 0, 5. And there's no rounding issue there. So is the question, and then is 5 a large value? Is it more than chance? Right? So we have this code. We need to do this simulation. That's a little duplicate there. So to evaluate that, we want to modify this code to generate many samples. Let's just make it 1,000. We don't need quite that many. And compute medians, right? So we need to change it in a few places. Do you want to try to change the code, right? You could rename things medians if you want to. That's not real critical. It would overwrite. It's going to be medians, right? Yeah, the real substances change is that this function here has to be medians. So go ahead and work on that. Where did it jump to? And that's the modification. I'm going to change a few names here so I don't overwrite everything. If it does something like this, so I was trying to type median. It tries to get something, you can either press tab to get through it, or escape to get it to stop having the fill in. And sometimes it seems annoying, but it's much better to have it than not have it, so. Send it. Here it is. All right. list something new too. Different median. Then that will save all the other, not overwrite anything. Not that you really need to do that, but. See if I can- Somebody want to run theirs and see what we get?
Interesting.
Did it run for you?
Yep.
Yeah. So. Oh. Mhm. Five, yeah, 5 and -5, that's what
That's good.
Okay.
I'm not, like, taking that, like, I lost my
Oh,
So,
Okay.
I understand.
yeah, so if you got that,
I got
our script in.
Yeah, I got ours just working.
Last week, last week.
That was the
Yeah.
This has
Yeah, you can. Grab.
There we go.
I'm taking notes
Wait,
right
no.
now because my night account is completely locked
Oh,
out.
it's 'cause it's like
So I can't hit
that one
cameras.
Were you able to download?
Yeah, it's just like I press on the wrong things and then I re-download
What
it.
did you get for your son?
Like, well, how do you shut it? Let me like close out and make this one so I can.
Try Control minus and see if it will go smaller. Let's see.
Oh, thank you, yes. Alright, let's see.
But is it going okay? Some of the modifications? Or?
Yeah, my canvas won't load, so I can't get the.
Oh.
I don't know why it's not. I disconnected the Wi-Fi, but I don't know.
Can you just sort of show the modifications?
Yeah, so the type of modifications I did.
Oh, you typed needed.
I just renamed it. Let's just change the name so it doesn't overwrite the other things that I had made, right? Before I called it mean 37. I just changed the names there.
Yeah.
Right. And I put a little dot. Names in R can have little dots after them. They can't have minuses or other computational
Underscore
symbols.
can you do for names?
Yeah, you can do
Or will that make it something else?
that. I think will make it something else.
Okay, so dots is names
Yeah.
instead of extensions like your columns.
Well,
Like
so
I said,
let's
Python.
test one. Say that is that test.
You did,
Yeah, so you can have underscores
Okay.
as names, right? Underscores can be in names or test.1, put a dot there, 9.
That's what you got.
So test.1 now is an object that has a value of 9, so you can use dots. So you can be pretty flexible.
What did you want?
And it is sensitive to case, so uppercase, lowercase. So in survey sampling, I often have,
Less than we got.
big and little n's, right? Big N and little n, because it's a sample size and a finite population size, so. Yep. A lot of flexibility. So that was a change. And then the other change is just changing this from means to medians, right? Because the test statistic is going to be difference of medians, right? That median's a function. So if you're like a median of, to get a string of values, you do C and then some values. So 5, 4, 7, just something like that, right? Median is returned as 5. And you can, if you click the up and down arrows, you cycle through things here, so that's kind of nice. And then you can do home or jump there. So these values, if I sorted them, the things that I typed, that's the sorted values. And the middle is there at 5, so the median happens to be 5 in this case. Right? So I changed the median
That's nothing.
there. And then this difference is the difference of ones. And then the things that come after that are simply changing these labels. So, yay. Right. Just changing these names to match what I did back up there. But the core change really was this change of medians, that you're computing something different. So if we run it, we'll just cycle through, keep running, it goes to the next one. And this is the difference of the medians that I got in simulation. It looks very, it's not exactly like yours. I'm not sure I did reset the numbers.
Sorry if I run out.
Yep,
All
yep,
right,
yep.
thank you. Have a good weekend.
Yep. Have a good time meeting the class? So this is the difference of medians. Set is null hypothesis, it's still around 0. It's kind of the range. It looks a little more choppy, like integers, right?
Yeah.
Right. But with the averages, the arithmetic averages, there's more of a kind of a rounding, but you know, the medians for both groups have to be integers, 0, 1, 2, 3, so the differences are all integers. So it ends up being a little more choppy. But our sample case was 5. Or -5 if you do the difference the other direction, right? This is almost symmetric, right? It doesn't really matter which side you go on. If I wanted to do one more change, I would change these limits. And then our number at 5 or -5 is just outside of that. The number of differences that are greater than 5 is 4. The p-value is something like 0.004 for one-sided. So in the homework, we'll have a couple problems that are just thinking about things that don't involve a lot of computing. And then there'll be a couple problems that use that airline data set. And it'll be a simulation very similar to this type of thing. So this code would serve as an example, but some code will be provided that kind of shows the details of, what are those variables named, how do you do that first processing to set it up. But the core loop and then some of the summary afterwards is going to follow very much like this, right?
That's so weird.
Yep. So Monday and Tuesday, I'll have office hours as well. So there's a couple chances to go over some of the computing, or if there's a problem with downloading or getting something going. Often the last year using it in classes, it was often that the first few steps were kind of frustrating, but then once you get them, then the rest of the semester is not greatly different.
Mine gave me 5 instead of 4.
5 and 6. So some of it can be whether I reinitialize the
See?
random number seed.
Okay, maybe that's it. It's close enough.
Yeah, it's not going to make a
Thank
really
you.
big- Yeah.
So we're doing the homework is on Canvas.
Yes. Homework's on Canvas. I'll add a sheet that's kind of our script of code.
I should let you know that I've been the ST450.
Okay.
It's on Canvas, but
Okay.
thank you for saying it's free, but I've run the other.
Oh, okay,
Sorry,
good.
Thank you.
Good.
Have a good weekend.
Yep. Yes.
So I probably won't be on the Canvas until Monday. The professor that I was trying to
Hey.
fill out the class for to switch into this
Yes.
one wasn't here this week.
Okay.
Um,
Bye, Emily.
Bye, thank you.
So for the homework,
I can
what
send you
should I do?
things.
Okay.
I'll send you the file.
Okay.
It's on an email.
Okay.
Thanks for letting me know about that. So
Yeah.
It affects a couple others too. So during this first week, then I can just email it to you when you get the.
Yeah.
I'm going to finish up the RScript file, and I'll send the other things.
Okay.
Yeah, and so I guess you've graded for Barbara O'Donovan
Yeah.
before.
Yeah.
Good.
Yep.
So
Yeah.
we've been straightening things out in the department with administration, and so there will be
Okay.
some funds for grading.
Okay.
I think she only needs grading for about an hour a week.
Yeah.
Professor Simons is teaching the other section of Math 150.
Okay.
And so between the two of them, there might be 3 hours a week.
Okay.
And so there'd be some things for her that she thinks will take about 1 hour to do.
Okay.
And some things for him that would take about 2 hours to do. If you're interested in both.
Yeah, I'd love to do both.
Good.